Hi guys, welcome back. As part of my special request videos, I'll be covering Maclaurin series in this video. What is Maclaurin series? You will have come across series and sequence in your high school. So when we say sequence, that is the arrangement of numbers in a definite order. For example, if I have 1, 3, 5, 7. You can see this is a definite order, and here we call it an arithmetic progression or an arithmetic sequence, because we have that the difference between the what? The two consecutive terms here is the same. For example, your second term, the difference between the second term and the first term here, that is 3 minus 1, is equal to the difference between third and second term and fourth and third term, like that. So which is equal to 2. This is known as your what? This is known as your common difference. So this is a series. So we also know that the sum of series is known as sequence. You understand now? So the sum of sequence is known as series. Sorry, so when you have 1 plus 3 plus 5 plus 7, like this. So that's what we know as sequence. Likewise, you've come across, an infinite series. When you can have an infinite series in such a way that when you have that, your sequence is what is infinite. So that it tends to what? It tends to infinity. So how do you now write a function as what? As an infinite series of as ascending powers of x. For example, if I have my f of s to be something of this nature, a plus bx plus cx squared plus ds raised to power 3 plus es raised to power 4 plus dot dot dot. So you will notice that this is your what? So this is also a series, an infinite series for that matter. So if you now want to write a function in terms of infinite series in an ascending power of x like this, so the mechanism you can use to actually do this is known as what? Maclaurin series. And how do you do this? When I have my function to be what? A plus bs plus cs squared plus c ds cube plus es raised to power 4 and so on. So where your A, B, C, D, and E here are what? Are constant. For me to know the value of this function and to check whether the function has all the values of the constant, it means I'm going to find the value of A, B, C, D, E are here. So to get it is not difficult to do. Then, for example, I can make my S to be 0 here. If your S is equal to 0, then I'm going to have that f of 0, that is where you see x, you put 0, plus a. If you put x to be 0 here, this will be 0, this guy will be 0, this guy will be 0, and so on and so forth. Then you conclude adequately that your f of a is equal to 0. So likewise, you can find the value of b as well. But here there is nothing you can do even if you put the value of a to be 0 here. For you to find the value of b, if you put s to be 0, you are still going to have your a left. So but what you can actually do here is to what? Is to find the derivative of your f of x. You understand now? And put the value of s to be 0 to find the value of b. So till you find all the constant, the value of the constant, you do that for c, you differentiate again, you put your value of s to be 0. So when you are doing that and you now have a series such that, you take the derivative of the function and you now put the value of s to be 0. So then when you now have such series, which I'm going to derive anyway, so we call it a Maclaurin series. And this Maclaurin series that I've said before is a mechanism, so you can use to express number as what? As an infinite series in terms of the ascending power of h, ascending power of x. Okay, to proceed now, if I now make my f prime of x You know your f prime of s now, that is to differentiate this guy, then I'm going to have derivative of constant is 0, derivative of bs will give me b 2cx 3dx squared, then plus 4 es raised to power 3 plus dot dot dot. Then you still put s to be 0, that is your f prime of s, sorry, f prime of 0. So f prime of 0 means wherever you see x before in the value of f prime of s, you substitute 0. Then this one will give me what? 0 plus b plus 0 plus 0 plus 0. So that implies that your b is also what? So that your b is equal to f prime of 0. Okay, now recall that I said we want to find the value of all the constants we have up there. And now we found the value of b. Let us find that of c as well. That is f prime prime of x. That is what you've differentiated here. Differentiate it again. This one will give me 0, 0, because b is a constant, plus 2c plus 6dx plus 12e raised to power 2 plus dot dot dot. Then we find f prime of 0, f prime prime of 0, that is, we want to know the value of c. Wherever you see s, you put 0, this will give me 0 plus 0 plus 2c plus 0 plus 0. So this implies that your 2c is equal to f prime prime of 0. Then if you make c the subject of the formula, then your c is equal to f prime prime of 0 divided by 2. So, and even you can write this as f prime prime of 0 divided by 2 factorial. So f prime prime of 0 divided by 2 factorial. Okay, to proceed, now I know the value of A, I know the value of B, I know the value of C. To find the value of D, you follow the same approach. But here, what you are going to do is to what? Is to differentiate. You find the third order derivative. That is the function you've differentiated here, you differentiate it. That's f prime prime of x. So if you differentiate 2c, that is constant, that will give you 0. This one will give you 6d plus 24e plus dot dot dot. Then you find your f prime prime of x as well. F prime prime of 0, you substitute the value of 0 here, then you are going to have 6d plus 0. That implies that your 6d is equal to f prime prime of 0. Then you can say that your d is equal to f prime prime of 0 divided by 6, which is also the same thing as f prime prime of 0 divided by 3 factorial. Remember, 3 factorial is 3 times 2 times 1, which is equal to 6. Okay, let us do the fourth one, because we want to know the value of e as well. So f fourth of 0, that is, you find the fourth order derivative. What you've differentiated here, we differentiate again, this will give me 0, then plus 24. You understand now? So then your f, that's f of x, sorry. So then your f fourth of 0 will now be what? 24. So am I making any sense? So yeah, because this is 6D here, then I think I'm missing something. Oh, that's EX. You understand? So that's supposed to be ES. Then if I differentiate this, then this is going to be 24XE, or you say 24EX. So then if you differentiate this, you are going to have what? So no. Okay, let's check that again. Yeah, so this will be S, this S raised to power 3, then 12 ES squared. Then if you differentiate it here, this will give you 24 EX. You understand now? So 24 EX, and I think this is going to give you 24 E. So 24 E. So now you can say that your E is equal to F fourth of 0 divided by what? 24, which is also the same thing as F fourth of 0 divided by 4 factorial. So you will see that I've found the value of my A here. We found that A is equal to 0. Then we found my B to be f prime of 0, and that your C is what? F prime prime of 0 divided by 2 factorial. Your D is what? f prime prime of 0 divided by 3 factorial. And lastly, E is equal to f worth of 0 divided by 4 factorial. So if you now substitute it into our function, the one I wrote before we started deriving it, let me show you again. So this function, yeah, this function I mean. So if you go back there, then I'm going to have that my f of s, recall that your f of x we said is equal to a plus bs plus cx squared plus ds cube plus es raised to power 4 plus dot dot dot. So because that is in an ascending power of what? In an ascending power of x. Okay, now if that is cleared, if you now make the substitution of what we've done so far, now we have that my f of s is equal to your a is 0, my b is what? F prime of x is my a0. Yeah. So f prime of x, your b is what? F prime of 0 x, right? Then plus, what is your c? F prime prime of f prime prime of 0 divided by 2 factorial. Then plus your d, f prime prime of 0 divided by 3 factorial. Then plus e. So remember your e is what? F naught of 0 divided by 4 factorial. So, and don't forget, this guy will give you what? Remember your a. Now I think a is what? F of 0. Sorry, a is f of 0, not 0. Let me show that to you. Can you see? Our a is f of 0. Yeah. So my a is f of 0. Sorry, it is not 0. A is f of 0. A is f of 0. So if you go back and make the substitution, if you go down and make the substitution, this is f of 0, f of 0. Then this give you, this is c, then you have to have s squared, s cube, s raised to power 4 plus dot dot dot. So in essence, we have that my f of x is equal to f of 0 plus s f prime of 0 plus s squared f prime prime of 0 divided by 2 factorial plus s cube f prime prime of 0 divided by 3 factorial plus s raised to power 4 f out of 0 divided by 4 factorial plus dot dot dot. Can you see that now? So you will observe that we now have this function in what? In ascending power of x as what? As an infinite series. So what we've done here, this is known as what? This is known as Maclaurin series. You understand that? So that is the mechanism you can use to take a function, I mean to what? To an infinite series in ascending power of n. So you can use this formula so to or you can write any functions in terms of the Maclaurin series using this formula. So let me use as an example the special one you are common with. Suppose my f of x, which is equal to e raised to power x. Suppose you want to write it in Maclaurin series. How do you do that? It is not difficult to do. Recall that my f of s, that's what? F of 0, it is not difficult, plus s f prime of 0, then plus s squared f prime prime of 0 divided by 2 factorial plus s cube f prime prime of 0 divided by 3 factorial plus s raised to power 4 f out of 0 divided by 4 factorial plus dot dot dot. So it means here I need my f of 0, I need f prime of 0, f prime prime of 0, f prime 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 of 0. You understand now? So That's what you are going to do here. Okay, let us do it. My f of s is equal to e raised power s. From here, I can say that my f of 0 is equal to e raised power 0. Remember, e raised power 0 is 1. You understand now? Okay, now let me find my f prime of x. Recall, don't forget we want f of 0, which is we found here. So we want to find the value of f prime of 0, but you cannot find the value of f prime of 0 unless you find the value of f prime of s. And recall, f prime of s means to differentiate the value of what f of s. So my f prime of s means to differentiate e raised power s. Recall that derivative of e raised power is also e raised power x. You understand now? Then your f prime of 0, that is whenever you see x here, you put 0. That should also be e raised power 0, which is equal to 1. Okay, now you find f prime prime of x. So that is you have to differentiate this function again. F prime prime of s will give you what? E raised power x again. Then you find f prime prime of 0. That will give you what? E raised power 0, which is equal to 1. Again, you can find your f prime prime of s. If you differentiate e raised power s again, you can see it is very stubborn. You are still going to have e raised power s again. Then f prime prime of s 0. That's e raised power 0, which is equal to 1. I used to advise people, the moment you have like you've generated 3 numerical constants here, you can stop. But if you like, you can still do it again. F out of x, that's e raised power s. Then your f out of 0 will give you what? E raised power 0, which is 1. So if that is clear, then you can now go back to your formula. Recall that our f of s is what? E raised power x. Then you can now say that your e raised power x, let me just change my marker so that it will make it more neat here. Okay, so then you can say that your e raised power s, which is f of s, that will now give you what? F of 0. What is f of 0? You can see that my f of 0 is 1. Then plus x. What is f prime of 0? That is also 1. Then plus s squared. What is f prime of 0? That is 1 divided by 2 factorial, right? Plus s cube. What is f prime prime of 0? That is also 1 divided by 3 factorial. Then plus s fourth of 0 is also 1 divided by 4 factorial. Plus dot dot dot. So if you write it properly, then you are going to have that your e raised power is equal to 1 plus x squared divided by 2 factorial plus s raised power 3 divided by 3 factorial plus s raised power 4 over 4 factorial plus dot dot dot. You can see that is simple. So that is what? So that is power series of what? Of e raised power x. That is, you've expressed e raised power x as what? As an infinite series in ascending power of s. So you can do other function as even your trigonometric function. Let's say you want to express sine x. So because these are the special function, your e raised power s, your sin s and cos s, and many of them, like even tan s, you can express them as what? As an infinite series in terms of s. So this is not difficult to do as well. Just write your formula. Don't forget, what you can use to express them is what we know as what? Maclaurin series. That's the mechanism you can use to subject the function to what? To ascending power in terms of x. So recall that your Maclaurin series of f of s is f of 0 plus f prime of 0 plus s squared f prime prime of 0 divided by 2 factorial plus s raised power 3 f prime prime of 0 divided by 3 factorial plus s4 of 0 divided by 4 factorial plus s raised power 5 f fifth of 0 divided by 5 factorial plus dot dot dot. So dot 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 means and so on. That is, you can have s raised power 6 f sixth of 0 divided by 6 factorial plus s raised power 7 the seventh order of 0 divided by 7 factorial. So again, we want to find our f of 0 here. So f prime of 0, f prime of 0, so f prime prime of 0, and so on like that. So you follow the same approach like I've done in the first example. Okay, now how do you do this? My f of s is what? Is sine x, right? This implies that my f of 0, since I need f of 0, that's sine 0. Don't forget sine 0 is 0, right? Okay, now my f prime of x, since I need f prime of 0, you cannot find f prime of 0 unless you find f prime of x. And now substitute the value of x into f prime of x to find your f prime of 0. Your f prime of x means to differentiate this. Derivative of sine x is what? Cos x. You understand now? So then you have f prime prime of 0. You have, f prime of 0. That's going to give me cos 0, which is 1. Then you have f prime prime of s, that is, you differentiate this guy again, that will give me minus sin s. The derivative of cos s is minus sin s. Then your f prime prime of 0, that is what? Minus sin 0, which is equal to 0 again. Your f prime prime of s, that's going to give me minus cos s. If you find f prime prime of 0, that's going to give me minus cos 0, which is equal to minus 1 because cos 0 is 1. Then you find your f of x, you differentiate this guy again. Derivative of cos x is minus sine, minus times minus, this will give me sine. Then your f of 0, that is sine 0, which is equal to 0. Then your f fifth of x, that's what? So cos x. Then your f fifth of 0 will give me cos 0, which is equal to 1. So if that is cleared, you can substitute it again. Remember that your f of x here is sine x. Then I'm going to have sine x. Your f of 0 is 0. X, what is the value of f prime of x? That is 1. Plus, what is x squared? So my x squared is, okay, you put your x squared, f prime prime of 0, that is what? That is 0 divided by 2 factorial. Let me move up a little bit. So, okay, now, then plus s raised by 3. What is f prime prime of 0? That's minus 1 divided by 3 factorial. Plus s raised by 4. S fourth of 0 is 0. F fourth of 0 is 0 divided by 4 factorial. Then plus s raised by 5. F5 of 0 is what? 1 divided by 5 factorial. You can see I said the moment you have like two numerical terms here, three numerical constants, you can stop so as to not waste your time. So if you substitute this further, this will give me 0. That's x times 1, that's x, this also 0, right? Then you have minus s raised by 3 divided by s factorial, then plus s raised by 5 divided by 5 factorial plus dot dot dot. That's how you can get for sine. In fact, you know the next term here will be what? So that's what s raised by 7 divided by 7 factorial. So it is not difficult. You don't have to memorize it. Recall that your sine is an odd function. So, and don't forget all this like 1, 3, 5. So then you have 1, then the sign will be alternating. You understand now? So let's say we want to express cos s in what? In terms of what? Maclaurin series. Even without doing it, I can have my answer. I can obtain my answer here directly before even doing it. How do you do that? Recall that derivative of sin s is cos s. So it means if I differentiate each of these terms, I should have cos. Now if you differentiate this, derivative of s is 1, right? Then this will give me minus 2s squared, 3s squared divided by 3 factorial. Recall that 3 factorial is 3 times 2 times 1, right? Then plus 5s raised to power 4. So divide by 5 factorial, that's 5 times 4 times 3, or let me say 5 times 4 factorial. Then s raised to power 7, that's 7s raised to power 6 divided by 7 times 6 factorial. This guy will cancel this guy. So this will cancel this. What do you have left? That's 1 minus s squared plus s raised to power 4 over 4 factorial plus s raised to power 6 over 6 factorial. Can we show that? Okay, now let us check that out and see if we are going to have it. Okay, now, yeah, again, equal to my f of s equal to cos s, and we have to express it in terms of power series. We should use Maclaurin series to what? To convert it to, a series, an infinite series in terms of what? In terms of the ascending power of x. Recall that your Maclaurin series is f of s, which is equal to f of 0 plus s f prime of 0 plus s square f prime prime of 0 divided by 2 factorial plus s cube f prime prime of 0 divided by 3 factorial plus dot dot dot. Okay, now it means since my f of x is equal to cos x here, so then your f of 0 is cos 0, which is equal to 1, right? You differentiate it since I need f prime of 0, and I told you you cannot find your f prime of 0 unless you find your f prime of s and you now substitute the value of s to be 0. So f prime of s is equal to what? So minus sin s. And your f prime of 0 will now be minus sin 0, which is equal to 0. F prime prime of x, if you differentiate this guy again, you are going to have minus cos x. Then f prime prime of 0 will now be minus cos 0, which is equal to minus 1, right? F prime prime of x, if you differentiate this again, that's going to give me sin x. F prime prime, f prime prime of 0, that is what? Sin 0, which is equal to 0. Then you can find f out of x, that is cos x. Then f fourth of 0, that is cos 0, which is equal to 1. You can see I have what? 3 numerical constants, and I advise that the moment you have 3 numerical constants, you can actually what? You can actually stop there. You can actually stop there. So if that is cleared, then you can substitute the values of this function. So then you have that your cos x, which is your f of s, right? We are substituting into the formula now. What is your f of 0? That is 1 plus s, f prime of 0 is 0, right? X square, f prime prime of 0 is what? Minus 1 divided by 2 factorial. Then plus s cube, f prime prime of 0, that is 0 divided by 3 factorial. So then plus s raised to power 4, you know, if I write it here, this is going to be s raised to power 4, f of 0 divided by 4 factorial. That's so s raised to power 4. So, and don't forget your f of 0 is also 1 divided by what? Divided by 4 factorial. This is 0. Then if you simplify further, you will see that I'm going to have 1, this guy will be 0, this guy will be 0. What do I have left? Minus s squared divided by 2 factorial plus s raised to power 4 divided by 4 factorial plus dot dot dot, which is equivalent to what I said you will get here. Sorry, this should be negative. So which is equivalent to what I said you will get here. So far we've generated 3 of them. You understand now? The first one is I said my e raised by summarily I said my f of s is in Maclaurin series, f of 0 plus s, f prime of 0 plus s squared, f prime prime of 0 divided by 2 factorial plus s cube, f prime prime of 0 divided by 3 factorial plus dot dot dot. So likewise, I derive e raised by s for you, that's 1 plus x plus s squared over 2 factorial plus s raised by 3 divided by 3 factorial plus dot dot dot. Likewise, for your sin s, I also derive it, say the same thing as s minus s raised by 3 divided by 3 factorial, s raised by 5 divided by 5 factorial plus dot dot dot. Then for your cos s is what? 1 minus s squared divided by 2 factorial. You understand now? So plus, so I think it is 1 plus s squared divided by 2 factorial minus s raised by 4 divided by 4. Is it? Let me check it. No, I think it is negative, sorry. You know, if you differentiate this, this is 1, then this is going to give you minus, and this is plus. You understand now? So that's that. If you want to do tan, it is not difficult, just differentiate it. Okay, now your question now says, let's say I want to solve this kind of question. Example. So use Maclaurin's series to expand f of s equal to s cos s. That is not difficult. Recall that your f of s equal to solution. You can do this in 2 ways, but the first method is this, which is very simple, which is more like the one you've done before. Your f of s will be what? That is what? Okay, let's do it together. f of 0 plus s f prime of 0 s square prime prime of 0 divided by 2 factorial s raised by 3 f prime prime of 0 divided by 3 factorial plus dot dot dot. You understand now? Then you come back here, your f of s is s cos x. Then I can find my f of 0 directly. Your f of 0 will be what? Wherever you see s, you put 0, that's 0 times cos 0, which is equal to 0. Any number you multiply by 0 will give you 0. Okay, now you find your f prime of x. F prime of x means you are to differentiate this. Recall you are going to use your product rule. So if you want to use your product rule, that is, you differentiate the first, you leave the second as it is, plus differentiating the second, leaving the first as it is. Okay, differentiate the first, that will give me 1. Leave the second one as it is, that's cos s, plus differentiating the second, that is minus sin s, leaving the first as it is, that is x. Okay, now then you can find your f prime of 0, sorry, that is whenever you see s, you put 0, that's going to be cos 0 plus 0. Irrespective of this value, the moment you multiply by 0, it will give you 0, then you have 1, because 0 is 1. Okay, find your f prime prime of x as well. If you differentiate this guy again, derivative of cos x is what? Minus sin x. You understand? So derivative of cos x is minus sin x, and you have like, this guy is like you are having minus sin x. This is also a product rule because this is a function, this is another function. Don't forget I told you you are going to differentiate product rule. So you differentiate the first, that's minus 1, leaving the second as it is, that is sin x, plus differentiating the second, that is cos x, leaving the first one as it is, that is what? Minus x. You understand now? So if you now find your f prime prime of 0, minus sin 0 will give me 0. Is that taken? So if that is the case, so this one will give me 0, and this is 0, but this will give me minus 1. Do you know why it is minus 1? This is minus. If you put 0 here, no, this is going to be 0 as well. Sorry, that's going to be 0. Because your s is 0 times 1, that will give you 0 back. But let me write this appropriately. This is same thing as minus sin x, then minus sin x here as well, minus s cos x. You understand now? So that is that for your f prime prime of x. Okay, let me find f prime prime of x again. That is, you differentiate this guy. Derivative of minus sin x is minus cos x minus what? Minus cos x. Then if you differentiate this guy again, this product rule. So differentiate the first, that is 1. You understand? Leave the second as it is, that is cos x, plus differentiating the second, that is sin s, leaving the first as it is, that is x. So then this one will give me, okay, let me find my, let me rewrite it better. This will give me minus 2 cos x minus cos x minus s sin x. If you simplify it further, minus 2 cos s minus others will give you minus 3 cos x. You understand now? So minus 3 cos x, then minus s sin s. You understand now? So okay, let us find f prime prime of 0. That is, whenever you see s, you put 0. That's going to give me minus 3, and this guy will be 0 because 0 times this will give me 0. Okay, now let us proceed. So we have f out of s. We don't have like a 3 numerical function, 3 numerical constants yet, and like I've advised, you have to have 3 numerical constant before you can actually stop. So okay, let us differentiate this. This will give me 3 sin S. I hope you understand how it is. Okay, now if you apply product rule, this guy will give me differentiate the first, that's 1, leaving the second as it is, that is sin S, plus differentiating the second, that is cos X, leaving the first one as it is. So that is X. You understand that? If you open the bracket, this is going to give me 3 sin X minus sin X minus S cos X, which is same thing as what? 2 sin X minus S cos X. You understand now? Then your effort of 0, that will give you 0, because if you put 0 here, if you put 0 here, you are going to have 0. Is that okay? Okay, now let me find f-fifth of x. You differentiate this function again. Derivative of this will give me 2 cos x. You understand now? Then minus, you have to differentiate it. Differentiate the first one, that is 1. Leave the second one, that is cos. Plus differentiating the second, that is minus sin s. Leaving the first, that is x. You understand? So if you open the bracket, this is going to give me 2 cos x minus cos x, then plus s sin s. So that's the same thing as cos x plus s sin s. So then your f-fifth of 0 is going to give me 1, because cos 0 here is 1. Okay, now then you can now move to your formula. Recall that we say our f of s is what? F of 0 plus s f prime of 0 plus s squared f prime prime of 0 divided by 2 factorial plus s cube f prime 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 of 0 divided by 3 factorial plus dot dot dot. And if that is the case, your f of s, which is what we are finding, that is s cos x. What is your f of 0? Let me check here. Our f of 0 is what? Is 0. Okay, go back. Let me scroll down so that you can see it very well. Okay, f of 0, as we can see up here, f of 0 is 0, right? Then plus our f prime of s is 1. You can see f prime of s is 1. Okay, let me just change my marker. So that is 1. Then plus s squared f prime prime of 0, I think that is also 0. Then plus s cube f prime 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 of 0 is what? What is f prime prime of 0? Let's check that. F prime prime of 0, that is minus 3 divided by 3 factorial. Recall this is 2 factorial. Then plus s raised to power 4, f out of 0, it is 0 divided by 4 factorial. Then plus s raised to power 5, f fifth of 0, it is 1 divided by 5 factorial. Plus dot dot dot. Then if you rewrite this guy very well, then you are going to have s cos x equal to, this is 0. This guy will cancel this guy. This guy will cancel this guy. Then what do I have left? I have x, right? Minus 3s raised to power 3 divided by 3 factorial. You understand now? So then plus s raised to power 5 divided by 5 factorial plus dot dot dot. So plus dot dot dot. So that's that. That's you've expanded it in what? In terms of the Maclaurin series. So likewise, I said you can use another method. Let's see if that is going to work. Recall that I have s cos x. You understand now? You don't need to stress yourself. Just find the Maclaurin series of these things. This is x. If you put s in terms of series before, it's going to give you s as well. This x, that is one term series. You understand? So then you can say x multiplied by, recall that this one will give me what? What is the Maclaurin series of cos s, like I've explained the other time? Record this one minus s squared divided by 2 factorial. You understand now? Then plus what do we call it? S raised power 4 divided by 4 factorial plus dot dot dot. So if you open the bracket, this one will give me x, right? Then minus s raised power 3 divided by 2 factorial, then plus s raised power 5. Am I communicating? So s raised power 5 divided by 4 factorial plus dot 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 dot. You understand now? So s raised power 5 divided by 4 factorial plus dot dot dot. So you will see here that this guy is the same with this guy. You know, 3 factorial is also the same thing as 3 times 2 factorial. It means 3 we cancel this, then we are left with what? S cube over 2 factorial. Then I think we've made mistake here. This is supposed to be 4 factorial. We had, let me see if there is anything wrong with the last expansion here. Let me redifferentiate this guy again. We have something of this nature. This will give me 2 cos x. Okay. We differentiate the first one, x. We leave the second one as it is. That is cos x. Then plus differentiating the second one minus sin s, leaving this first one as it is. Then if you open the bracket, 2 cos. Yeah, I think it is worth taking out because s raised power 5 divided by 5 factorial. But likewise here we just have what? We have s raised power 4 divided by 4 factorial. I think there is something wrong. There is something wrong here. Let me check this, what we've done here again. Here we have that minus 3 cos x minus 3 sin s. If you differentiate this, oh, I think this guy is negative. You know, we have negative here, right? Okay, cos s. That means so that's 3 sin s. Then we have minus here. Differentiate the first, leave the second one as it is. Plus differentiating the seconds, leaving the first as it is. That's 3 sin x minus sin x. You understand? So then minus s cos x, that's 2 sin x minus s cos x. Okay, if I differentiate this guy, that is 2 cos x minus cos x. Yeah, I think I'm correct. Perhaps you can check that anyway, or if we've made any mistake, you can just correct it. But I'm very sure we should be able to have something like this. So we should be able to have something like this. Oh, by the way, how do I have no, I think I made a mistake. Okay, s raised power 5, s raised power 5 divided by what? Divided by 4 factorial. S raised power 5 divided by 4 factorial, and we had 5 factorial here. Yeah, so you guys can check what is the, perhaps when we were differentiating here, so we've actually missed a negative number also. So let me simply rederive it here so that I can get it quickly and see what we have. We have s, f of s is what? Now we have f of x. Sorry, I will do the second one. F of s is equal to s cos s, right? Then my f of 0 is equal to what? 0. F prime of x, differentiate the first one, leaving the second as it is, plus differentiating the second, that will give me minus sin s, right? So f prime of 0, that's going to give me 1. If you differentiate this again, then that's going to give me what? Minus sin x. You understand? So then minus, if you differentiate this, that's going to give you sine x. We've differentiated the first, we leave the second as it is, plus differentiating the second, that is what? So that is sine s. Differentiating the second cos s, leaving the first one as it is, that is x. You understand? So then I'm going to have minus 2 sine x minus s cos x. You understand? So if you find f prime prime of 0, that's also give you 0. Okay, what of f prime prime of x? If you differentiate this guy again, so this will give me minus 2 cos x, right? Then differentiate the first one, leaving the second as it is, cos, plus differentiating the second, that's minus s sine x. So then this is going to give me minus 3 cos x minus s sine s. You understand? Then if you find your f prime prime prime, f prime prime of s, that's going to give you what? Minus 3. So that's going to give you minus 3. Yeah. Okay, now f what of x, f what of x, that's going to give you 3 sine x, right? Minus, if you differentiate this guy again, so that's going to give me what? 0. That's going to give you, no, derivative of s is 1, derivative of sine s, differentiate the first, leave the second as it is, plus differentiating the second, that's cos x, then x here. So then I'm going to have 3 sine x minus sine x minus s cos x. That will give you 2 sine x minus s cos x. You understand now? So minus s cos s. If you put f fourth of s, f fourth of 0, that's going to give you 0. Okay, let us find f fifth of x. Derivative of this will give you 2. Derivative of this will give you what? 2 2 cos x, then minus, differentiate the first, that's 1, leave the second as it is, cos x. Differentiating the second, that's minus sine s, leaving the first as it is, x. Then if you open the bracket, I'm going to have cos x. Yeah, I think I'm correct. So I think I'm correct, which is going to f fifth of x is going to, f fifth of 0 is going to give you 1. Yeah, that will give you 1. I think since we stopped at fifth term and the third term, that's why, I mean, we couldn't find something that we cancel each other, because we are still going to have something, I mean, like other terms as well. So that's that. I think that's how you are going to do that. Okay, for the second question, when you have your f of s equal to s squared e raised power s, that's not difficult. What are you going to do? You can find your f of 0 directly from here. That is what? 0. Okay, now let us find my f prime of x. Recall that your f prime of s will give me what? That is, you differentiate this, differentiating the first 2s, leave the second as it is, e raised power minus s, then plus differentiating the second, that's minus e raised power minus s, leaving the second as it is, that's s squared. And that give you 2s e raised power minus x minus x squared e raised power minus x. Then your f prime of 0 is going to give you, if you put 0 here, this is going to be 0, this is going to be 0, and this also going to be what? This also going to be 0. Yeah. Can you see, if you continue doing it like that, you are going to have 0, 0, 0, 0, 0. You understand now? So you are going to have 0, 0 because your s is there, and the moment you are differentiating, so you are going to have it. Okay, let's try the third one. Let's say I differentiate this again, f prime of x, you know, this one is going to give you, it's a product rule as well. So this is going to, you differentiate the first, that's 2, leave the second as it is, minus s, plus differentiating the second, that's minus e raised power minus s, leaving the second as it is, that is minus 2x. You understand now? So then you differentiate this guy again, differentiate the first, that is 2s, right? Leaving the second as it is, e raised power minus x, plus differentiating the second, that's minus e raised power minus s, leaving the first as it is, s squared. If you open the bracket, that's 2e raised power minus x. You understand that now? Then minus 2x. Am I communicating? Yeah, minus 2s e raised power minus x, minus 2s e raised power minus x, then plus minus x squared plus s squared e raised power minus x. You understand? So you will see that I think 2 e raised power minus x, then minus 4s e raised power minus x, plus s squared e raised power minus x. If you put 0, this guy and this guy will go, it will remain this guy here. And e raised power 0 is 1, this will give you 2. You understand? Is that taken? Okay, then you can find f prime 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 of x again. Okay, let us differentiate this. You differentiate this, that's going to give me minus 2 e raised power minus x. Okay, let us differentiate this. It's a product rule. Differentiating the first, that is 4. Leaving the second as it is, minus e raised power minus s. Differentiating the second, that's going to give me minus 4s e raised power minus s. You understand now? So that is done. Then plus, what of this guy? Differentiating the first, let me write, I think f prime prime of 0 give us 2, right? Differentiating the first here, that's 2s. Leaving the second as it is, minus x. Then minus e raised power minus s squared. So then you have minus 2 e raised power minus x, minus 4 e raised power minus x, plus 4s e raised power minus x, plus 2s e raised power minus x, minus s squared e raised power minus x. You can collect the like times. This guy is minus 6 e raised power minus s, plus 6x e raised power minus x. Am I communicating? Then minus s squared e raised power minus x. So your f prime prime of 0 will give you what? If you put the value of 0 here, so that is 1 minus 6. The rest of these guys will be 0, because 0 will affect this and it will be 0. Let us do it and have one more numerical variable. Okay, let me find effort of x. So your effort of x is going to give me what? My effort of x is what? So what is minus 6? Let us differentiate this. So derivative of this is going to give me 6 e raised power minus x. If we differentiate this, differentiate the first, that's 6, leave the second as it is, e raised power minus s, minus 6s e raised power minus x. Then differentiate the first one, that's minus 2s e raised power minus x. So then plus x squared e raised power minus x. So f4 of x is going to give me 12 e raised power minus x, minus 8s e raised power minus x, plus s squared e raised power minus x. So then you have that. If you find your effort of 0, that's going to give you 12. Can you see that now? Then I found that my f prime prime of 0 is equal to 2. F prime prime of 0 is equal to minus 6. And f fourth of 0 is equal to 12. Okay, now if I substitute into my power series, into my Maclaurin series. Recall that your Maclaurin series is equal to f of s, and don't forget f of s is f of 0 plus s, f prime of 0 plus s squared, f prime of 0 divided by 2 factorial, s cube f prime of 0 divided by 3 factorial plus dot dot dot. Then f of x, which we are finding, we are finding the value of s squared e raised power minus s. So your f of 0 is equal to what? That is 0. S times 0. Then x squared multiplied by f prime of 0 is what? 2 divided by 2 factorial. Then plus s cube, that is 6. So that will give you 6s cube divided by 3 factorial plus 12 s raised power 4 divided by 4 factorial. You see that this guy will cancel this. So this guy will cancel this. This guy will cancel this. And what do you have left? You have x squared plus s raised power 3 plus s raised power 4 plus dot dot dot. So plus dot dot dot. So it means your s squared e raised power minus s will actually give you this. So we actually give you this. Sorry, I hope I didn't get any negative result here. Let me check again. Yeah, no. I think my f prime of s is minus 6. Sorry. So this should be negative. Minus 6. So minus 6. And this is going to be what? Minus 6 as well. And this is going to be minus s raised by 3 as well. I hope you understand. So alternatively, what you can do is to express, we know that e raised power minus s, if you express it in Maclaurin series like I've done the other time, if you do it one by one. So I think since e raised power s give me 1 plus s squared, this is our later alternatively. So plus s squared over 2 factorial plus s cube over 3 factorial plus dot dot dot. You understand now? So but e raised power minus s, that is whenever you see s you put negative, that's going to be 1 minus x plus s squared, because minus s squared will give me s squared over 3 factorial over 2 factorial minus s cube over 3 factorial plus s raised power 4 over 4 factorial minus s raised power 5 divided by 5 factorial plus dot dot dot. You understand now? Okay, what will be the Maclaurin series of s squared? F of s is this, right? So when you find your f of 0, that is 0. When you find your f prime of x, that is 2s, right? F prime of 0 will also be what? It's going to give you 0, right? So f prime of x, that is 2. You understand now? And f prime of 0 is equal to what? Is equal to 2 as well. So you will see that if you substitute it to the, Maclaurin series, so f of 0 is 0, f prime of 0 is equal to 0, only f prime of 0 is equal to 0, is equal to 2. And don't forget, the term of f prime of 0 is what? S squared divided by 2 factorial. What you have here, which is f prime, 2 will cancel 2, that's s squared. So you don't need to stress yourself. So that's how I explained the other time. So your s squared multiplied by what you have here, that's 1 minus x plus s squared over 2 factorial plus what? Plus minus, sorry, s raised by 3 divided by 3 factorial plus s raised by 4 divided by 4 factorial plus dot dot dot. So if you open the bracket, this guy will give me s squared, you understand, minus s raised by 3, so minus s raised by 3. So then if you multiply this will give me plus s raised by 4 divided by 4 factorial, s raised by 4 divided by 4 factorial. So if you still open it, this s raised by 6 divided by 6 factorial, you understand now. So if you go and go like that, so you are going to have it. So, but it is strange because we are not getting the last term. No, let's see. Yeah, I think I'm wrong. 1 plus s squared, yeah, and this e raised power minus x. This already expanded in Maclaurin series. Okay, s squared minus s cube plus s raised power 4 divided by 4 factorial. Yeah, so this how you are going to do it. I am very sure there are some terms so that make it stop here. In essence, if you continue multiplying like that, perhaps you are still going to see what you are going to marry with s raised power 4 in such a way that this guy is going to cancel away. So you can see we have something that is actually what? So that is actually the same thing. So that is that. So that's how you are going to approach Maclaurin series. If that is clear to you, please don't forget to subscribe to my channel. Thank you.